Hello everybody, and welcome to the Cellebrite webinar on the topic of accessing digital data from Huawei devices. My name is Yochai West, and I am a Senior Product Marketing Manager at Cellebrite, and I will be your presenter for this webinar. In today's webinar, I'll give an introduction of the newest capability, Huawei Decrypting Bootloader. I'll explain when and why to use the Decrypting Bootloader capability. I will also give tips and tactics and best practices on how to use the Huawei Decrypting Bootloader in your cases. Let me now give you an introduction to Huawei Decrypting Bootloader capability. It is the newest capability from Cellebrite Security Research Labs after previously released Smart ADB and Decrypting EDL. Huawei Decrypting Bootloader is a lock bypass physical extraction for full disk encryption device and also a full file system extraction for file-based encryption devices. It is targeting Huawei devices with HiSilicon Kirin chipset. The supported chips in the capability are 620, 650, 655, 658, 659, 930, 935, 950, 955, and 960. Examples of the supported devices include Mate 9, Arrow 9, P9, and P10. For additional information, please refer to the UFED release notes. This capability, as mentioned before, is targeting both full disk encryption devices, FDE, and also file-based encryption devices, FBE. What accessories will you need to perform an extraction? Due to the simplicity of the extraction, you will only need your UFED or infill cable 100. If your device has micro USB Type B, or cable 170 if your device is equipped with USB Type C. Why and when will you use Huawei Decryption Bootloader? Huawei Decryption Bootloader is a very simple extraction method. It requires no advanced practice and no special cables. It will require to insert the device to fast boot mode, which is very simple, and from that point, it would perform the rest. It is a generic capability that is targeting the chipset. Therefore, if a device has a curing chipset from the supported list of chipsets, but it wasn't tested by Cellebrite, you will most likely get an extraction. The new capability passes the device encryption to provide an unencrypted extraction. Therefore, no additional method needed to apply. In the following section, I will suggest best practices. The best practices will include 3 extraction flows: extraction flow for full disk encryption devices, extraction flow for file-based encryption devices, and how to use Cellebrite generic profile. I would like to start by an example of full disk encryption. I have selected Honor 5C as an example. Let's have a look at the device ID. Honor 5C was released to the market in May 2016. It has a Kirin 650 chipset. At the time of the release, the Android operating system was 6.0. That means the device is encrypted out of the box. Other market names are Honor 7, Lite, and Huawei GT3. After connecting the device to UFED and identifying the specific profile, please select Physical Extraction. You will then be notified that the physical extraction also provides a lock bypass. In the physical extraction, you will see an additional method that hasn't been available before, named Decrypting Bootloader. It will also carry an icon of lock bypass. You will need to select this option. After selecting Decrypting Bootloader, please follow the instructions in UFED. You will need to make sure your device is turned off. You will then need to insert the device to fast boot mode. In this example, you need to press the volume down button while connecting cable 100. After a few seconds, the device will enter fast boot recovery mode. You will be able to identify it by seeing the fast boot screen on the device. UFED will also enable the continue button to continue to the extraction. After pressing the continue button, UFED will automatically perform the extraction. You can follow UFED's screen for the steps of the extraction. Once the extraction is finished, the extraction is completely decrypted, and you can continue and open it in UFED Physical Analyzer. After explaining the full disk encryption, I will now continue to explain the file-based encryption. I have selected the Mate 9 as an example. Mate 9 was released to the market in December 2016. It is equipped with Kirin 960 chipset. It was released with Android 7, and you can see an example of the device models. Connect the device to UFED to find the right profile. Select File System Extraction Method. In File System, please select the newest method, Decrypting Bootloader, File System button. It wasn't available before. After selecting Decrypting Bootloader Full File System, please follow UFED instructions. You need to make sure your device is turned off. Please press the Volume Down button and connect the device to UFED using cable 170. After a few seconds, Fast Boot Recovery Mode screen should appear on your device, and the Continue button in UFED should be enabled. From this point, similar to the previous extraction flow, UFED will automatically perform the extraction. If you have in your possession a device that Cellebrite doesn't have a specific profile for, that means it hasn't been tested here. It is recommended to use the Huawei Decrypting Bootloader generic profile. In the following slide, I will explain to you how to use the generic profile to get an extraction. If your device is not recognized by UFED, or you couldn't find it by entering AutoDetect or IMEI or its ID, you will now be able to browse manually and select Huawei Profile. Inside Huawei Profile, please select the generic Android. Note that it is colored in blue and can easily be identified. Now you will see the available extraction methods. You will need to select physical extraction or file system extraction. This is depending on the device encryption. I will explain how to locate the device chipset and the encryption in order to successfully perform an extraction. To locate the device chipset, I want to suggest the following. We have encountered many Huawei devices that have an embedded model number in the back of the device. You can also locate, in some cases, the IMEI. With this information, you can use helpful links such as IMEI Info or GSM Arena to locate the device chipset. After locating the chipset, you will now need to understand what encryption type does the device have. Now, not all the time is this data available on the internet. We in Cellebrite have summarized the devices that have encountered into a table. You can find the devices that have full disk of file base and use it as a reference. Now that I have located the chipset and the encryption, I can now move on to select extraction type. Let's take this example. I have in my possession a device which I have identified as a full disk encryption. I've also managed to identify that is equipped with Kirin 950. The best practices for me will be the physical extraction. In the physical extraction screen, I will need to select the decrypting HiSilicon Kirin 95X chipset. From that point on, it is exactly the same as the other extraction flows. I want to thank you for watching the Cellebrite webinar. I hope you found it useful. For additional information, you can use UFED User Manual or use UFED Release Notes. If you need further assistance, please contact UFED support.